everyone, Chang here and welcome to my channel. This is the skill building video series where basically we pick a specific skill and we practice it so that when we encounter a problem that actually need that skill, we can solve it with ease. Let's begin. So for today's video, we're going to be focusing on solving basic linear equations. Now, I'm going to put a sort of 1-2 step guideline, but here's the thing. To solve basic linear equations or just future problems in that matter, the best thing to do, the best way to approach it is actually to be kind of fluid, to be flexible. The way it works is that it's not 1, 2, 3, 4, 5 kind of steps that you have to follow to solve the problem. If not, you are incorrect. That's not the case. Each and every problem is subtly different, so you have to tailor your approach to each and every one of the specific problems. But hopefully this generalization will help you build this general understanding of how to solve basic linear equations. Now, the first and foremost is you have to figure out what the variable you're solving for is. All right, remember this, when you're solving basic linear equations, you're basically trying to find what number that variable actually represents. First, find the variable. The second thing is to isolate that variable. Now here's where you sort of get creative. All you know is that you want that one variable on one side of the equation, everything else is on the other. So here's two sort of guidelines to remember, and everything else is fair game. First and foremost, you got to remember this. What you do to one side, you must do to the other. This is an equation. That means they are both equal. What's on the left and on the right is equal to each other. So if you all of a sudden start working on the left side by adding, subtracting, multiplying, and dividing things without doing it to the right sign, you just violated that equal sign. So make sure what you do to one side, you must do to the other. The second thing is to identify what operations you're actually doing. The key or the hint is that every time you want to get rid of something, you want to cancel something out. Like if a variable is adding something, what you're going to do is you're going to do the opposite. If it's adding, you're subtracting. If it's subtracting, you're adding. If it's multiplying, you're dividing. And if it's dividing, you're multiplying. So hopefully this will help. Let's just put in some practice and see what happens. So I'm going to start off with this problem. This is a fairly easy problem, right? Just so you guys can get used to the idea of doing the opposite to solve for the variable. In this case, we have x minus 5 equals 9. Once again, we want to isolate our variable, x. That's the only variable we're worried about. That's the only one we're solving for. So we want x on one side of the equation, everything else on the other. But remember, this is an equation, so what I do to this side, I must do to this side as well. Well, it's x minus 5, so if I want to get rid of that 5 and it's subtracting, I got to do the opposite. So the opposite of subtracting is adding. So what I'm going to do is I'm just going to add 5 on both sides. Remember, add 5 here. Then I have to add 5 here. What I do to one side, I must do to the other. Well, negative 5 or subtract 5 plus 5, that cancels out, becomes 0. That's why it's canceled out, right? 9 plus 5, in this case, is just 14. Well, we still have our x. We didn't do anything with the x, and we can still bring our equal sign down. So, in this case, we got rid of the 5, added it on the other side, and now we have x equals 14, and that is our answer for this problem. Now, the second problem, 1 over 3 times x equals 4. Now, I specifically emphasized the times because that's exactly what it is. 1/3 times an x equals 4. So this is an example of, multiplication. You got to do the opposite. Remember, we're worried about x. We're doing the opposite. Since this is a times, we have to divide. Now, here's where it can get a little murky, right? Because it's 1/3 times x. Now, what you can do is actually divide by 1/3 on both sides. So let's just do that. We're going to divide by 1/3, divide by 1/3. Now, 4 divided by 1/3 is the same as 4 times 3 over 1, which is just 3, which gives us 12. Okay, so this gives us x equals 12 as our answer. Okay, now here's the thing though. I'm gonna get rid of all this. Let me just get a way to get rid of all this. And the reason I wanted this specific problem is because it seems kind of weird. Because you'll see people solve it a different way. So you have 1 over 3 times x equals 4. Now, a common way that people solve it is I'm going to multiply by 3 on both sides. But that makes no sense, right? Because this is already a times. Why would you do times again, just try to cancel things out? Well, it's actually based on the idea that 1 over 3 is just basically sort of, if you rewrite this, is x divided by 3, or x over 3. So this thing right here can be written as x over 3, which is basically x divided by 3. So if you wanted to do the opposite, in this case, when you look at the problem this way, you actually multiply on both sides. And notice that overall, even though we cancel, and now we have x equals 4 times 3 again, this is x equals 12. The answer is still the same. So it's based on how you interpret the problem. Luckily for this case, we just interpret it and it's basically the same meaning, right? 1 over 3 times x is the same as x over 3. That's why we had the version where we divided 1/3 on both sides, got x equals 12, and this version here where we multiply 3 on both sides and we still have x equals 12. Now for this problem, this is a wonderful problem highlighting basically a combination. We have a multiplication here with 8 times x, but we also have an addition here of -5. So what we do in this case is we're going to solve it, get rid of everything, and once again have x by itself and everything else on the other side. Now I've seen online that they advertise or they advise that to solve these kind of problems, the best thing to do is to get rid of all the numbers that's furthest away from the variable first. So in this case, since x is here, the furthest away is the -5, get rid of that, and then get closer and closer to the variable itself. And I think that's a pretty good way of going about it. I feel like there are going to be some problems where that advice might not work. I can't think of one right away, but that's why I'm a little hesitant in presenting that. But again, you're trying to find x by itself. Be creative, don't break any rules, and then you'll be fine. So let's just follow that advice. First and foremost, let's just get rid of that -5. This isn't adding, right? So you want to subtract a -5, or in this case, you can just, since it's a -5, all you have to do is, well, plus 5. This goes away, it becomes 0, and so you're going to do it on both sides. So plus 5, this goes away, so then this is going to be 0 plus 8x, and this is going to be plus 5 here. So we have now 8x equals -4 plus 5 is just -1. Divide by 8 on both sides, because once again, that's a multiplication, do the opposite, divide, right? Now you have x equals -1 over 8. And that would be the answer for this problem. Alright, so for the remainder of the video, I'm going to refrain from giving an explanation. Hopefully you guys can follow along. But here's the thing, keep in mind, if you solve it a different way, that's entirely fine. It doesn't have to be step by step the way I did it. As long as the answer is the same, you got it. So, let's begin. Thank you so much for watching this video on solving basic linear equations. See you in the next video.